we do have a test on Monday. Remember, it is chapter 3, the end, the last two sections on solutions, and all of chapter 4. There is a little bit in chapter 4 near the end called combustion analysis, which we haven't done. So if you're looking through chapter 4 and you're like, oh my gosh, I don't know how to do this, that won't be on your test. You will see older tests that have that on there. I just haven't had time to get to it. The questions will look like, if I burn this hydrocarbon and I get this much carbon dioxide and that much water, what's the empirical formula? So that is not going to be on this test. If you come across those, please don't panic. I want to remind you that we have some extra credit things coming up. So next Wednesday in this building, in the big lecture hall downstairs, we have a webinar on the hidden life of spices. This is a program in a box that ACS sends me. So they gave me all kinds of like things to hand out. So there's scratch and sniff stickers that smell like cinnamon and vanilla and nutmeg, and I have a ton of those. And there's keychains and pens shaped like chili peppers and all kinds of things. So I have tons of stuff I need to give away. So please come and take the things from me. And then and so we'll start doing things at 6:30. We'll raffle a few things off, and there'll be some trivia. So there'll be prizes for people who win trivia points, and then there'll be a speaker that will watch, probably a couple of speakers. They haven't given me the details on this, that talk about the different ways you can think about the chemistry of spices. So it should be pretty interesting. On Saturday, not 2 days from, or not tomorrow, tomorrow's homecoming, but a week from tomorrow at the public library, there is a volunteer event where usually it's elementary school kids that are there. And we do things like make slime with them, but we also try to do things related to the theme. And I am really struggling with stuff that I can do with little kids that teaches them about the chemistry of spices. So one of them is just going to be, I'll have Play-Doh that has cinnamon in it. And, you can talk about, ooh, what does it smell like? So really not hard volunteer work if you can tolerate being around little kids. Um, so yeah, you can get, for the second one, 10 extra credit points for staying for an hour. I'll have a sign-in sheet on Monday, where I'd like some people to show up, like 15, 30 minutes early to make sure that we have everything in the room and that it's set up and ready to go. We usually have people hanging outside the door, 10 or 15 minutes ahead of time. I'm like, are you ready yet? Are you ready yet? Um, and then I'll ask for some people to stay like 15 minutes late to help me clear out our stuff and get the room back in order. So if you can sign up for one of those time slots, that would be super helpful. And any questions? All right. And it is occurring to me, I should probably double check and see if there's anything on active that would help you prepare for the exam that I haven't put up yet. So let me take a look at that. I think I have. I don't see anything not assigned here. So yes, so there's nothing new on active, but do take a look at some of those practice things. Is there anything that you want more practice problems on that I can try and put up over the weekend that you can practice with? That is already there. Okay, if you think of something that you're like, oh gosh, I wish there was a way to practice this, email me and I will try to get that up today so you'll have an opportunity to practice that over the weekend. Okay. Here, I would like for you to pull out, oh no, wait, you don't have this yet. So we're going to talk about oxidation numbers first. You will notice that I have put on the table in a cover sheet the same handout that I gave you on oxidation numbers. So what I will do is either having them in these sheets, or I might just send them the whole page, make that the back of the cover sheet. But in any case, you will be provided with the rule. So you need to be able to follow the rules, but you'll have that, because I know we just started doing that. So you will need to pay attention. Okay, some reminders about, aside from oxidation numbers, things that we had talked about on Wednesday. All of my chalk is disappearing. Always hide a stash. Okay. So oxidation is losing electrons. So this could be an element that is becoming positive. Our metals, we say, get oxidized. So when we talk about rusting, we're usually talking about iron. Iron's version of oxidation is rusting, but almost all metals will oxidize in some form or another. And so that oxidation process, which is their equivalent of rusting, is them losing electrons. And if we don't know where those electrons go, we can just write them as a product going off somewhere. So what happens is we increase the oxidation number. Now we could also have something that was negative be gain the electrons or lose the electrons and go from negative to neutral or negative to less negative. So let's say I had, I'm trying to come up with a good example. If I have chlorine minus and it becomes chlorine the element, that is also an oxidation process. Okay. Reduction is gaining the electrons. And so remember, this is like that weird thing. If it's reduction, why is it gaining the electrons? Well, we're thinking about the charge or the oxidation number. So we reduce the oxidation number. And so we could have something that is becoming negative. So we might have oxygen going to oxide. And so it has to get those electrons from somewhere. That could be oxygen in the air is hanging out with a metal and picking up electrons from that metal. And so it becomes oxides. Or we could have something that already has a positive oxidation number getting to a lower oxidation number. So we could have something like N2O5, oops, little 5, going to N2O3, and we'll ignore the oxygens for the moment. But this is the nitrogen being a +5. This is the nitrogen being a +3. Okay. Notice that the same rule applies here for finding the charges, the oxidation numbers, as we would for the charges in an ionic compound. So oxygen is that -2 oxidation number. The nitrogen is 5. So we're just swapping those numbers. Same thing here. We swap those numbers and we have a +3 there. So an easy way to find this. Am I getting? I am getting all of that. Okay, we call the thing that takes away the electrons, so the thing that is taking these electrons from the copper, it is oxidizing the copper, okay? So the oxidizing agent, or sometimes it's the oxidizing reagent, takes electrons. So if it is taking the electrons, it's gaining them, and it is reduced. So common oxidizing agents might be oxygen, especially in organic chemistry. Those of you taking organic chemistry next year, the most common thing that is going to oxidize things is going to be something that has a lot of oxygen in it. Okay, so the oxygen will be taking the electrons. Chlorine can be an oxidizing agent. And then we could also have things with a lot of oxygen. So NO3 minus, ClO3 minus, ClO4 minus, and MnO4 minus. Notice they all have a -1 charge and a lot of oxygen. These items, if they have this ion in them, we have to separate them in the storage area because the oxidation reactions from them can be very strong, very violent, produce a lot of energy. Okay. And then similarly, the reducing agent is going to be something that is giving up electrons. It's providing electrons. And so it is going to be oxidized. In general chemistry, one of the most common ones is zinc because it's stable at in ambient conditions. You know, you don't have to do any special storage of it, but at the same time, it doesn't take too much, just a little bit of acid to get it to give its electrons up. So that's really common with general chemistry. With organic chemistry, you might be adding something with hydrogens in it. So we might have LiAl4, ALH4, and a similar compound with borons in it. Okay, so having a bunch of hydrogens does the opposite of having a bunch of oxygens. Okay, so what we're going to do then is we're going to put these ideas together by looking at some example equations. What? Oh, did we already? Okay, sorry. Never mind. Okay, so I already gave you this. All right. So first thing is I want to look at that first rule for oxidation numbers, which says if I have a neutral element, pure element, its oxidation number is 0. Now, I also told you that when we're looking at types of reactions, if we have a pure element, then it's probably an oxidation reduction reaction, because if it's a pure element on one side and it has to change, then it's going to have something other than that pure element oxidation number. So it's going to be oxidation reduction. So what I'd like you to do is look down through all of the equations and find all of the pure elements that are on that page, and then write 0 above them so that we know that those have an oxidation number of 0. Okay. So I'm looking at just B and C here because I don't want to write them all out right now. Were there any pure elements in the first one? No. Okay, so let's look at the second one. Pure elements? Yeah. Okay, so we see magnesium is 0, and hydrogen is 0. I can put the phases here. Okay, now our second rule was if we have a monoatomic ion, so one atom with a charge, whatever that charge is going to be the oxidation number. Do we have that appearing here? Yeah, in the magnesium. So I'm not going to write the +2 again because it's already there. Okay, so for C, it asks the question, is this a redox reaction? We know that it is. We have a pure element, and we can see that it is changing its oxidation number. So you're going to write yes in that first box. All right, so let's take a look at the magnesium. When it goes from 0 to 2+, is that oxidation or is that reduction? That's oxidation. Okay, so oxidation is losing electrons. Let's see, where do I want to put this? Remember, we have oil rig, or Leo says Ger, whichever mnemonic helps you. But in either case, the L goes with the O. Losing electrons is oxidation. Gaining the electrons is reduction. Okay, so under atom oxidized, we are going to put Mg. All right, these two things always happen hand in hand. That's why we call it redox or oxidation reduction. Those electrons can't just disappear. They have to go somewhere. So something else changed its oxidation number. So let's go and look at the other elements. Now, the other elements are hydrogen and oxygen. When they are not by themselves, as this hydrogen is, those always have the same oxidation number. So what is hydrogen? +1. And that's on both sides, both in the water and in the this ion. This is a polyatomic, more than one atom, cation. I told you there were only 2, and we've seen ammonium from time to time. This is the other one, polyatomic cation. And this is called hydronium. Okay, so it's a 1+, and what's the oxygen? -2. Okay, so we want to double check. Our last rule is that if we add up all of those oxidation numbers, we should get the charge of the particle. So right now the coefficient doesn't matter. If I add +1, +1, and +1, because there are 3 hydrogens, and a -2, if I add all of that together, do I get the positive charge? Yeah. Same thing over here. If I add 2 +1s and a -2, do I get a neutral charge? Yes. Okay. So did hydrogen change its oxidation number? From this side to that side. Some of it, not all of it, but at least some of it did. So some of it just went to water and it didn't change. But some of it turned into that hydrogen as an element. Okay, so where it says what atom is reduced, our atom that is reduced is going to be hydrogen. Okay, so when we ask what is oxidized or reduced, we usually write just one element. Now, when we ask about the agent, we usually put the whole chemical formula. So the thing that is the oxidizing agent is reduced, right? So the thing that was reduced was the hydrogen, but we're going to put the whole formula of where that hydrogen was found. So the oxidizing agent is going to be H3O plus, and the reducing agent, what is the thing that provide the electrons? The magnesium. And in that case, it is just the same thing. So we'll just write Mg. Okay. All right, now let's go back to this one up here, B, for the calcium carbonate. We have a rule for group 1 and group 2. Early on, we learned they always have the same charge, but also for oxidation numbers, they're always going to have their charge equal to their oxidation number. So for calcium, what is its charge and oxidation number? gonna be 2. So we would write +2 for the oxidation number. And then oxygen in compounds is gonna be what? Same thing as it was here. -2. So we have a -2 here, a -2 here, and a -2 here. And we can see our +2 and -2 balances out. All right, but the carbon we don't know. So we're going to have to figure that out. Okay, so take a second. Start with this one. This one's a little bit easier. And then on this side, I'll write out the algebra. All right, so what did we find over here? If we have 2 negatives, because the oxygen is -2, and we have 2 of them, so 2 -2s, we have a total of -4. So what does the carbon have to be to balance that? +4. And since carbon dioxide doesn't have a charge, we want that to exactly balance out. Okay, so the carbon is a +4 on the other side. So over here, we're basically doing the same thing, but since we've got lots of atoms in there, I'm putting them all in an equation. Okay, so calcium was +2, and there's just one of them. So 2 plus carbon, there's 3 oxygens with a -2, so -6 is equal to 0. So what is the carbon on this side? Also +4. Okay, so this is not an oxidation reduction reaction. So in that first box where it says, is it redox? No, this one's not. All right, so this begs the question that we also have elsewhere on your test. What type of reaction is this? Okay, so the first thing, the easiest thing to look at is how many reactants and products do I have? Based on the number of reactants and products, what kind of a reaction is this? This one is a decomposition. Okay, now if I only had one product, but I had several reactants, what kind would it be? Synthesis, or you could also call it combination or addition. Okay. All right. Let's look at, we're not going to have time to go through all of these, but look at D. We're going to find with those having the oxygen and hydrogen that are always going to be the same, the sodium that's always the same, the chloride is going to be a -1 on both sides. So that one is not redox either. What kind of reaction is that? It's an acid-base one, which we would call neutralization. Remember, neutralization has what 2 products? Water and a salt. Okay. And then the neutralization is one of 2 kinds of what kind of displacement? Double displacement. Okay.